Hello, everyone. I'm Xiaofan Zhang. Now I'm doing my business analytics graduation program in Ivy Business School. I worked for Gloss from May to early September as a cyber infrastructure analyst intern and have learned a lot about the Great Lake 2030. And I'm glad to be here and represent Gloss to share what we are doing for the Great Lakes with the Lakebed 2030 project by CrossPhosphorosymmetry. We highly appreciate this opportunity and welcome any follow-up questions and communications. Next, please. So please let me firstly briefly introduce who Gloss is. Gloss provides end-to-end data service which supports science, policy, management, and industry in the Great Lakes region. The Lakebed 2030 is one of the most important projects that is supported by CrossPhosphorosymmetry. Defined by IHO, CrossPhosphorosymmetry is the collection of depth measurement from vessels using standard navigation instrument while engaged in routine maritime operations. So the contributing vessels could be as big as a commercial ship or as small as a fishing boat. As long as it is equipped with proper hardware, it could become one source of our crowd. So here is what Gloss has done about CrossPhosphorosymmetry. So we are a part of the bottom mapping work group and have been looking for contributing vessels to support Lakebed 2030. We also did desktop study research, which analyzed the costs and approaches for mapping the Great Lakes. Part of this research is identifying new ways to collect cross-source bathymetry data through citizen science and crowdsources. Next, please. So now we are working with Orange Force Marine, who is a Canadian company in Port Stanley, to support Lakebed 2030. We funded its cross-source bathymetry hardware named Muscle Kit, which is shown in the left picture, and it has already been active with 10 vessels. We also funded a secondary project to develop more units, as well as a data processing pipeline designed by Orange Force Marine. And this data pipeline is currently applied to Gloss data flow. Next, please. So this slide shows our scale expansion plan. In the prototype stage, we involved 2 vessels. One is Orange Apex, which belongs to Derek Nils, the president of Orange Force Marine, and the other is CCGA Para, which belongs to Colin Thompson. Now we are trying to expand our fleet scale to 12 vessels in phase 2. In the future, we are looking forward to increase the number of data contributing vessels to dozens for phase 3 and beyond. Next, please. So to make sure that our data contributors have provided us with qualified data, we practiced data validation before extensive data ingestion. The first step is to collect the sample data, and we choose Port Stanley as the sampling spot. We adjusted the water depth sample with vessel movement, water level, etc. So that we would be able to compare the water datum with our adjusted data. So if the difference between the water datum and our adjusted data is acceptable, then we will have confidence to say that our data is of high quality. And the data visualization shows that the sample is aligned with datum, and there were only a few spots in the data where our single bin data needs to be edited. So these look like an area where the sonar lost bottom tracking or another error occurred. However, given the low number of these spots, they will not have a statistically significant effect on the comparisons. So other than visualization, we need to like apply more solid statistic evidence to support our conclusions. So we then apply the surface to surface and the surface to point analysis. The outcome is pretty good. So for CCGA para, the error could be narrowed down to 16 centimeters. And for orange apex, the error could be narrowed down even to 3 centimeters, which makes it qualify for IHO Order 1 standard. Next, please. So with the support of our high quality data, we could then satisfy the demand of our data workflow. Our CrossPhosphorosymmetry data collected by our contributing vessel will go through a cloud-based data pipeline and be processed. The final product will be grid files for the grid links. For further distribution, we will provide our cross-source bathymetry data to IHO database to fulfill international bathymetry data demand. We will also give data availability to CHS if need, and also the Office of Coastal Survey to contribute to maritime activity in the Great Lakes region. Next, please. So this framework shows how we collect cross-source bathymetry data. So the muscle cross-source bathymetry system designed by Orange Force Marine is a really important part of this workflow. It includes GPS sensor, IMU sensor, muscle data logger, and Wi-Fi. So firstly, the echo sounder will collect data, water depth data, and transfer them to NEMA 2000 bridge, where the GPS sensor data and IMU sensor data will be like included. And then all of this information will be transferred to muscle data logger and uploaded to Gloss Cloud via Wi-Fi. So after being processed properly, the cross-source bathymetry data will contribute to a Gloss ecosystem. Next, please. So this one shows more detailed information about how we're gonna process the data and where the data goes. This is a bimodal solution based on AWS and Paperspace. Firstly, the S3 AWS will ingest raw data from vessels and convert it to JSF file, then store them. And there will be two ways of the distribution of our cross-source bathymetry data. One way would be that we will produce XYZ file and transfer them to NDBC. And the other way is to use Chimera, QPS Chimera on Paperspace to pick up those data, amalgamate them into our dynamic data set to update our data resource as soon as possible. We will also process and convert them to bag files. So the bag files will be ingested into a Paperspace instance of ArcGIS Pro for development of a Mosaic dataset and grid production. And then the data set will be transferred back to AWS ArcGIS Enterprise for surface update, to make sure that we will like generate a continuous high density surface, and also will be deployed to Seagull, which is another very important project of Gloss via Mapbox. Next, please. So there will be a bunch of stakeholders who could benefit from our cross-source bathymetry data. It could assist boaters, commercial fishery, and maritime transportation in the routine maritime activity. For academic purposes, the data may support environmental research and geographic exploration. Governmental organizations also could use the data to support general maritime management and infrastructure deployment. So overall, people from all industry around the Great Lakes could potentially benefit from cross-source bathymetry data. Next, please. So how to get involved with us? We highly welcome data contributors to join us to expand the data collection skill as quickly as possible. So if you worry about the equipment, please get in touch with our partner who is Orange Force Marine, and they will be really happy to help with the muscle system installation, which will make you qualify for our data collector requirement. Last but not least, please spread the word about Lakebed 2030 and make more people care about and contribute to this region. Next, please. So what should GLOS focus on in the next stage? In order to satisfy our stakeholders' demand, we will expand the data collecting scale to ensure that our data is comprehensive. We will also continue increasing our exposure to the public so that we could attract more potential data collectors and data users. Recently, we are seeking the chance to become IHO's trusted node, and we're now in the final stage. In the future, we will develop more opportunities to enhance our engagement in the CrossPhosphorosymmetry ecosystem. As for data processing, pipeline automation will always be one of our goals, which would bring convenience not only for our workflow, but provide our data users with more real-time data. So to make sure all of this happen, we will keep raising funds and seek for any further potential partnership in CrossPhosphorosymmetry. Next, please. Yeah, so thank you very much for listening to my presentation. If you are interested in hearing more or participating in any way, please contact us at underwater@gloss.org. Thank you very much.
Thank you so much for that. Are there any questions for Xiaofan in chat or questions? I had a question. I was wondering, I'm not sure if you said this, but how much roughly does a muscle kit cost?
Yeah, it's a good question. Actually, I'm not really sure, but I believe it's it won't cost a lot because recently it has already been active in 10 vessels, and we will in the future install it like in a very large fleet. So I believe it will be a cost-friendly equipment.
Okay, Tim Kearns just notes in the chat that Gloss is funding them for now, so they're free. They're a bargain. So
they are pretty cost-friendly.
Yeah, very cost-friendly, exactly. I did wonder though, so there you have the muscle kit, and then what is the interaction with the mariner or the vessel? Is it you know, over the phone, online? Does someone have to come out and work with the crew? How does that part work?
Do you mean the interaction between Gloss and the vessels?
No, well, getting that muscle kit installed and set up to collect and operate. I think on one of your slides you had the Ocean Marine graphics saying that was part of they were part of the installation process or the connect. Yeah.
Which slides?
That
Okay,
one right there.
Okay, you mean the interaction of the muscle installation?
Yeah, I'm just wondering what the level of effort is to get things installed and operating. That's all.
Yeah, I think just email Gloss and we will connect you to Derek, which is our very close partner, and they'll help you like get the free muscle kit.
Okay, great. And Tim is like this voice from the cloud himself saying that OFM handles the installation and configuration. And then humans are not involved after that. The data magically flows to the cloud. So thank you, Tim. Let's see, Justin. Well, first, oops, I just messed up comments. Derek notes that Orange Force Marine would be pleased to work with organizations for installation. And then Justin Cooper asks, what is the communication mechanism between the GPS transducer IMU and the submitting device? Is it Bluetooth or USB connected?
I think this technology belongs to Orange Force Marine, so I'm not really sure about like the internal interaction between the IMU and the NEMA 2000 bridge.
Okay, well, maybe we could follow up with
Yeah.
Eric on that or get an answer into our for the record here. Colin, I think just echoes a comment that Derek made about OFM coordinating with the vessel owner, minimal effort involved to connect. Peter Esselman asks a good question. Who owns the original data at the end of the process? Is it essentially donated data, which is, you know, citizen science data? Is it gloss data? Is it?
I don't want to say that Gloss own the data. I think the data contributor does, and I think Gloss just want to be like the maybe Tim can like answer that from the chat box because like it's but sensitive.
Mm-hmm. Well, I think Peter expands to say, does OFM plan to commercialize the data at all? But Tim notes that it becomes public data. So vessel operators sign an agreement acknowledging that the data will be made public. So that's all sorted out at the beginning, which is good. Everyone's clear. So I know it feels like we're zinging questions at you, Xiaofan. I'm just reading though as we go. So thank you for your patience. All right, do we have any more questions? And I think Colin answers back to Justin's question, perhaps. Communication is across the MEA network. And one final comment from Tim. This is considered a prototype project, and we're working through the details and best practices. And I am very interested in how this evolves because, of course, you know, there are other crowdsourced Bathy projects going on, and I think we all want to learn from what you're doing and end up bringing this citizen science data into the DCDB and other places. Let's see. Yeah, Colin just says there's a user agreement defining ownership elements. All right, any other questions? And thank you, Tim and Colin and Derek for weighing in from afar.